A new interstellar object is racing through our solar system.
We should check whether each and every object that arrives into the inner solar system is just a rock, icy rock, or maybe a technological gadget.
Harvard astrophysicist Avi Loeb says this object isn't just space debris, it may be evidence of something more.
If something turns out to be alien technology, we can learn about technologies that we haven't developed. Moreover, if we end up realizing that it's a threat, the consequences of such a threat would be extreme, collapse the world economy.
And not everyone in the science world is ready to hear that.
Neil deGrasse Tyson is a popularizer of science. He's not a practicing scientist. You are not in a position to protect science if you are not practicing it. I bet you that if Neil deGrasse Tyson existed a century ago and people were starting to discuss quantum mechanics, he would say, that's crazy.
Hey everyone, I'm Matt Ford and welcome to the Good Trouble Show. Today we're talking about a brand new interstellar object making its way through our solar system. To help us make sense of it, we've got one of the top minds in the field, a Harvard astrophysicist, director of the Galileo Project, and best-selling author. His book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, is available wherever books are sold. He's been stirring up the conversation about life beyond Earth, our conversation with Dr. Avi Loeb. Dr. Loeb, welcome to the show. The last time I saw you was on Capitol Hill at the UAP Disclosure Fund Experts panel. How have you been?
A lot has happened. One thing that was unexpected was the discovery of a new interstellar object on July 1st, 2025. And of course, we never invited this guest, but it might be interesting to figure out what it means.
Yes, and I want to jump right into that. So as you said, we have this new interstellar object passing through our solar system. What is it? And like, I have no idea what interstellar means. I'm kind of not a science guy. So explain that for us.
Well, it's an object that is moving too fast to be bound by gravity to the sun. So there is a threshold speed above which the gravity of the sun is not strong enough to bind an object. And we have seen 3 of them with telescopes over the past 8 years. The first one was discovered in 2017 by a telescope in Hawaii called Pan-STARRS. And this object was named Oumuamua, which means a scout in the Hawaiian language. And it was quite anomalous. It was most likely flat in its shape. The brightness of the object changed by a factor of 10 as it was tumbling. And that meant a very extreme shape. And it was also pushed away from the sun by some mysterious force without showing any evidence for evaporation. There was no cometary tail around it. And we just couldn't figure out what is pushing it. I suggested it's just a reflection of sunlight. And in fact, 3 years later, the same telescope in Hawaii discovered another object pushed by reflecting sunlight, ended up being an upper stage of a 1966 rocket that was launched by NASA. And the question is, who produced Oumuamua? The name means a scout in the Hawaiian language. And then in 2019, there was a comet that came from interstellar space discovered by an amateur astronomer, Gennady Borisov, and it's called Borisov, and it looked just like a comet, a very natural object. And now we have 3I Atlas. It's an object discovered by the Atlas telescope in Chile that was surveying the sky, a half-a-meter telescope that basically scooped the Rubin Observatory that is just next door, that was inaugurated in June 2025. It was funded at almost $1 billion by the National Science Foundation, by the Department of Energy. And it has an aperture of 8.4 meters, much bigger than the half-a-meter telescope that discovered 3I Atlas. So in a way, the Atlas telescope scooped Rubin, and the Rubin team was able to go back to their data from the early the beginning of June, and they found this object in the data. It was challenging to detect it because it comes from a direction of the Milky Way galaxy center. So there are plenty of stars there. It's a very crowded field, and that's why it was discovered only on July 1st. But the Rubin Observatory is expecting to discover a new interstellar object every few months. So we are now entering a new era where the detection rate of interstellar objects will increase by almost a factor of 100. And every few months we'll know about a new one. And I see that as an important development because we should check whether each and every object that arrives into the inner solar system is just a rock, icy rock, or maybe a technological gadget. You know, maybe among the rocks we'll find a tennis ball that was thrown by a neighbor. Now, this object, 3I Atlas, actually has a lot of unusual features. As soon as it was discovered, I was actually interviewed that night on Coast to Coast. So I woke up at 2 a.m. and then one of the listeners emailed me about the discovery, and I looked into it. I realized this object is bright, and if the brightness is just the reflection of sunlight from a solid surface, then the object needs to be 20 kilometers in diameter. That's bigger than Manhattan Island. It's twice as big as the rock that killed the dinosaurs 66 million years ago. And such giant rocks are extremely rare. You know, Oumuamua was about 100 meters in diameter, comparable to the size of a football field. And, you know, this one is up to 200 times bigger. And so first, why would we observe small objects, you know, like Oumuamua, and then also Borisov was roughly the same size, a few hundred meters, and suddenly a giant rock? You know, that makes no sense. And moreover, there is not enough material in interstellar space to give us such a rock over a decade. You know, if you do the statistics, this kind of a giant rock should be found once per 10,000 years or longer. And we haven't surveyed the sky for that long. So I was thinking maybe it was on a mission, you know, to target the inner solar system. And then I realized that the trajectory of the object is actually very well aligned with the plane of the planets around the sun to within 5 degrees. And the chance of that happening at random is 1 in 500. So it makes that trajectory very special. Also, the arrival time is extremely fine-tuned so that the object passes close to Mars, Venus, and Jupiter. And the chance of that happening at random is 1 in 20,000. So I thought maybe there is some intelligence that designed this trajectory. And, you know, obviously you may ask, why would they do that? And there is this dark forest hypothesis as an answer to Fermi's paradox. Enrico Fermi, back in 1950, asked during lunch at Los Alamos, discussion among friends on extraterrestrials, he asked, where is everybody? And one possible answer is that, you know, they're silent. The aliens are not very far away, but just the way you would behave in a dark forest is you would worry about predators, so you wouldn't make a sound. And then if they keep monitoring us, because we've been broadcasting for a long time, for a century, at some point they might do reconnaissance missions and visit us. And so that could explain a situation like the one we are encountering.
So I want to go back and talk about the trajectory again. So let's consider for a moment that maybe this is not guided. When an object, some kind of interstellar object like this, passes by other stars or the sun, you know, you were talking earlier, I think, about Oumuamua maybe being propelled by the sun. If this object going through different systems, passing by different stars, would those stars adjust the trajectory every time it goes by? In other words, it would not be sort of like a linear thing. Would it push it out of the way? And if so, would that further support your contention that this path really does seem like it is being guided?
Yeah, I mean, if you imagine just sending an object that cannot really maneuver at all, just sending it out, the chance of it flying so close to a star like the sun is extremely small, actually, even if you wait billions of years. Because the space is so vast. However, if it was targeting the inner part of the solar system, then of course all bets are off. Now the question is, where did it come from? And it took it about 8,000 years to arrive to our neighborhood from the outskirts of the solar system at 100,000 times the Earth-Sun separation. That's the edge of the Oort cloud, where the solar system ends. And I define here the solar system as all the bodies that are bound by gravity to the sun. Okay, so I mean, people sometimes say, "Oh, Voyager just left the solar system." That's not true. It just passed the location where the solar wind, the flow of particles coming out of the sun, is being stopped by the interstellar medium. That has nothing to do with objects being bound to the sun. You know, we see objects all the way out to 100,000 times the Earth-Sun separation. So that's the edge of the Oort cloud. And it took it 8,000 years to arrive to us from there. And if it started the journey, let's say at 1,000 times the Earth-Sun separation, you know, it would have taken 80 years for us for it to reach us. If it started the 100 times the Earth-Sun separation, that's the Kuiper belt. That's where, you know, we see, that's the distance out to which we see, you know, objects that are somewhat smaller than a planet. Then it would have taken it only 8 years to reach us. So the question is, you know, we wouldn't see a 20-kilometer object beyond a distance of 10 times the Earth-Sun separation. It's simply too faint. It doesn't reflect enough sunlight. We don't know where it started the journey and why did it start the journey. And so I suggest just monitoring such an object using all the assets that we have in space, on the ground. So we have ground-based telescopes. We have the Hubble Space Telescope that already imaged it. And the amazing thing about the image is that there is no evidence for a tail, the way you see around comets, where dust particles that are ejected from the comet are being pushed back by the solar radiation pressure, and that creates a tail away from the sun. We don't see that. Actually, all we see in the Hubble image is some glow ahead of the object, not behind it. So it's moving towards the sun, and there is some glow ahead of it. It's really fascinating to see. So what is producing this glow? I mean, if it were dust, small dust particles that, you know, are of the same size as the wavelength of sunlight, which is half of a micrometer, then they would be pushed back. I calculate within a day they will trail behind the object. We don't see that trail. So it's not clear maybe it's something else. But at any event, the glow that we see is very little material. You know, over a period of 6 months, the amount of mass loss from an object of 20 kilometers in diameter amounts to less than a millimeter thickness. So it's just the skin of the object. If you just have dirt on the object, that would appear the way we see it right now. It's not a lot of material for a 20-kilometer sized object. So the question is, what's the nature of this object? We don't know. And I think we should observe it.
So the fact that it appears to be emitting its own light, and we don't know how that is happening, and the fact that this trajectory really sort of seems like a perfect sort of flyby of our, you know, of our planets, it really kind of lends. I can understand why you would say that there is a very decent chance that this could be not just some random thing.
Yeah, I mean, it's not clear that it produces its own light. It may be just reflecting sunlight with, you know, a large surface. But I defined a new scale that is now called the Loeb Scale for classifying interstellar objects. I did it last month, inspired by 3i Atlas, where, you know, 0 implies a natural object, like a comet, where we can see the cometary tail. 10 implies a definitely technological object that is also a threat to humanity because it's maneuvering and approaching Earth, for example. And on this scale between 0 and 10, I currently rank 3i Atlas 4.
Okay.
Because we don't have a direct evidence that it's technological, but I think we should monitor it. And for example, there is a camera that is with a 0.5 meter aperture that is currently orbiting Mars. It's called HiRISE, part of the Mars Reconnaissance Orbiter. And I contacted the team, encouraged them to observe 3I Atlas when it comes close to Mars. On October 3rd, it will be within 29 million kilometers from Mars. And a pixel on that camera corresponds to about 30 kilometers. So it could actually give us quite a good image, and not much coarser than the actual size of the object. Then there is also a spacecraft called Juno around Jupiter. And if it had all the fuel that it had originally, I calculated that it would be able to intercept 3I Atlas when it passes close to Jupiter on March 16th, 2026. But even with a very small amount of fuel, it can get close to it within 25 million kilometers or so. And a day after I published a paper about that, I had a phone call from Congresswoman Ana Paulina Luna, who asked me for an update about 3I Atlas, and I mentioned the opportunity to use Juno, and very graciously, and she wrote a visionary letter to the head of NASA, the interim administrator of NASA, Secretary of Transportation, Sean Duffy, encouraging NASA to look into that. And I very much hope that we will get as much data as possible, because then if it turns out that it has anomalies, these anomalies will not be pushed under the carpet of traditional thinking. It wouldn't be possible to do that. The one mistake the church, the Vatican did is when Galileo told them, I look through my telescope, I see moons orbiting Jupiter, therefore not everything revolves around the Earth. So instead of putting him in house arrest, they should have said, we have more money than you do, we can build a bigger telescope, and we will prove you wrong. And if they were to do that, they would have found that he's right very quickly. But instead, they put him in house arrest, and then 350 years after he died, they announced in 1992 that he was right. Now, that was very embarrassing for the Vatican from a public relations perspective. Yeah, exactly. Right. I think I very much hope that anyone that wants to prove me wrong will collect as much data as possible, for that reason, that if it turns out that I'm right, then we will know about it quite quickly. Now, the one thing I was asked today, actually, I had two interviews, one by the Times in London, and the other one, there was a gathering of more than 100 high net worth individuals that had a Zoom call with me. And in the first one, I was asked, I asked myself, actually, at the end of the interview, I said, will I be happier if we realize that 3I Atlas is a comet? And naively, I said, actually, yes, because then there is no threat to Earth, and we can continue to live our lives. But then in the second conversation, I was asked, why should we invest in your research?
Wow,
and
okay.
I said, well, first of all, if something turns out to be alien technology, then we can learn about technologies that we haven't developed, and that would take us a long time to develop, and that could be very profitable. Moreover, if we end up realizing that it's a threat, the consequences of such a threat would be extreme. It could collapse the world economy, and so under any of these scenarios, it makes a lot of money, a lot of sense to invest money in the research to figure it out. In the worst case scenario, we just develop sensors and algorithms for analysis that could be helpful for the Department of Defense, if they monitor the sky.
Yeah, I couldn't agree more. I mean, we definitely need more scientific investment into this, into the UAP issue. I'm curious, in your conversations with NASA, did they seem receptive to retasking these spacecraft to observe this interstellar object as it passes by?
Right. So the HiRISE camera next to Mars, when I spoke with the principal investigator, he was very forthcoming. He said yes, they will do their best, and I'm looking forward to the data. That will be October 3rd. With respect to Juno, it's really interesting because this mission was launched in 2011, and the research team would like to extend it. I mean, originally they planned to crash it into Jupiter in mid-September 2025, and I said instead of pushing it towards Juno, just towards Jupiter, just push it away from Jupiter, and that will give you an extended mission, more funding. But their immediate reaction was to say, yeah, we would love to have additional funding to continue the mission, but we will use it to look at Jupiter. So because we don't have a lot of fuel, it's not clear whether NASA will support them for an extension of time unless they have something exciting to report back about other than looking. But we should see what happens because they need to get their act together in September. And so that there is not a lot of time. And if the alternative is to crash it into Jupiter, instead of extending the mission by at least six months to observe 3I Atlas, I hope they would see the light.
Hey, folks, we're going to get back to our interview with Dr. Avi Loeb in a few minutes. He has some interesting things to say about Neil deGrasse Tyson. But first, over half of you watching right now are not subscribers. So please help us grow the Good Trouble Show by becoming a subscriber to this channel. Hit the subscribe button and then hit the little notification bell right next to it so you will always be up to date on our latest shows. We are also on all the major social media platforms. You can find us on X at Good Trouble Show and everywhere else at The Good Trouble Show. You can also find us wherever you enjoy your podcasts. Search for The Good Trouble Show with Matt Ford. And if you would like to become a supporter of The Good Trouble Show, please join us on Patreon by going to www.patreon.com/The Good Trouble Show. Your support allows us to bring you great guests and shows like we have today with Dr. Avi Loeb. Now, with that out of the way, let's get back to our interview. I certainly hope so, too. And I certainly hope that other members of Congress, in addition to Anna Paulina Luna, will message NASA as well and say, hey, you know, this is important. It seems pretty black and white to me that this is an opportunity to look at something that could possibly be of non-human origin and and to pass that opportunity up, I think. I mean,
even if you think that it's definitely a comet, which would be a conservative take on it, it's a giant nucleus that we are talking about. You know, at least a few kilometers in size, and maybe even 20, if we just don't know. And then such a giant rock does not come to our backyard very often from interstellar space. So let's figure out everything we can about it.
And again, if I remember correctly, you said this thing is the size of Manhattan?
Well, if it's the 20, so if the brightness that we see is not coming from the dust around it, but mostly from reflection of the solid surface of the object, then, and by the way, the dust is not opaque. We can see through it, okay? So based on the analysis of the Hubble image, but we just don't know what the size of the object is. And it could be if most of the light that is reflected comes from the object, then it needs to be of the order of 20 kilometers in diameter. And, you know, the reason I say that's a realistic possibility, despite what my colleagues are saying, is because when we see what we see by taking a spectrum of the object is that it's red. There is reddening. And so, you know, one interpretation is to say this reddening is associated with dust particles that are making it redder. But for that to happen, the particles of dust need to be roughly the size of the wavelength of sunlight in order to scatter sunlight and make it appear redder. But in fact, if that were the case, then the solar radiation would push very effectively such particles and would make a very nice appearance of a cometary tail, which we don't see. So my assertion is we probably do not get the reddening from the dust particles. And in that case, it must be that the surface of the object is red. And as a result, the 20-kilometer estimate is a viable estimate for the size of the object, because it's not being most of the light is not just related to the dust scattering it, but related to the object reflecting the sunlight. So it's a big object, and it's hard to imagine how such a giant rock would arrive to our backyard. But the fun of doing science, as I said many times, is that you don't need to know the answer in advance. And the reason that many of my colleagues in academia are very reluctant to consider the possibility that it might be technological is, because the comet experts are basing their expertise, their stature, all the honors they get, the funding they get on past knowledge. They looked at comets in the past. They would argue this one is a comet. They will not take a risk at suggesting that it may be something else. But nature does not care what we think. The Earth continued to revolve around the sun for 4.5 billion years before the Vatican even existed. So whatever the Vatican said is irrelevant, because the Earth was moving at the same time around the sun. The fact that they didn't recognize it, who cares? And the fact that on social media or among some academics, they argue that this must be a comet. If it's not a comet, it doesn't really care about what we say.
Sure.
It is whatever it is. And for us to be smarter, to show some level of intelligence, we really need to get as much data as possible about it to figure it out.
Exactly. And, and you said this is going to be in our backyard, but I'm glad that this literally is not going to be in our backyard. I mean, something like this.
We don't know that. So when NASA says this one will not be a threat to Earth, they assume that it will continue along the path dictated by gravity. Okay. And in that case, that's coming back to your previous question. There is a little bit of deflection by the sun, but not a big one, because this object will be moving at 68 kilometers per second closest to the sun. It will get closest to the sun on October 29th, 2025. And actually, the Earth would be on the opposite side of the sun at that time. And we won't be able to observe it because the sun will be in our way. And you might say, well, maybe that was designed as well. We can't launch rockets to intercept it, and it may do a maneuver because that's the perfect timing for getting gravitational assist from the sun and slowing down the spacecraft. And in that case, it could visit us. But there could be also, it might also be a mothership that releases mini probes. And in that case, that may explain why it comes on a retrograde trajectory, meaning it moves opposite to the direction of motion of the planets. And if it releases mini probes, then they would actually be moving opposite to the planets, and they can easily intercept the planets. It's much easier for them to reach the planets than to chase the planets from behind. And so I asked the research team of the Galileo Project to, we built 3 observatories. They will start full operation by the end of September 2025. And I asked the research team to monitor the data, and we have machine learning software that can tell us the rate of anomalous objects in the sky. And I asked them to see if there is an uptick in the rate of anomalous objects in the sky after October 29th. And, in the months after that, we will look at the sky and see if there might be any side effects of the passage of 3I Atlas.
Yeah, that'll certainly be interesting to see if there is indeed a change. I want to talk about for a second your most recent article on your blog titled "Is 3I Atlas Made of Antimatter?" which folks can find your blog at www.avi-loeb.medium.com, which always has your latest work. I love reading your blog. It's really informative.
Yeah, I should say I had over the past month of order 500,000 readers, which it's for me, I've never witnessed something like that, because I'm not talking about tweets. I mean, I wrote about 43 essays since 3I Atlas was discovered, and people are just reading them and commenting about them and sending me a lot of emails, hundreds of them every day. And just to give an example, a couple of nights ago, I got an email from a U.S. pilot, a former pilot in the U.S. Air Force, and he wrote, I mean, the title of the email was "Because of You." And the content of the email was that because of me, his son and daughter are now fascinated by science. They might want to be scientists, and they keep speaking about aliens. And that was perhaps the most moving email I ever got, because for me, inspiring young kids to do science is extremely important and exciting, because if they look at traditional questions with a fresh mind, they might discover important things. And, you know, the CERN, for example, invested $10 billion in the Large Hadron Collider. I find it hard to believe that if they were to find an elementary particle, that any a pilot might write to them and say that his son or daughter decided to pursue science just because there was this particle discovered like this. But somehow people connect to this research subject in a way that affects their lives. And I see that everywhere. And the fact that scientists avoid this subject is really strange, because we are, as scientists, we are using taxpayers' money. And if there is a subject that appeals to the public, it's this one. And, how can the mainstream of the astrobiology community argue that we should spend all of our resources, very little on the search for intelligence, extraterrestrial intelligence, and more than $10 billion in the next 20 years just in the search for microbes, which is pretty much what they're saying. And I find that as a missed opportunity, because the public so much cares about the intelligence option, and even though microbes might be far more abundant, if you look at your street, you see a lot of houses, and we look at our cosmic street and we see a lot of Earth-Sun analogs. There should be billions of them in the Milky Way galaxy alone, and of course microbes may be very abundant over there, but to find evidence for them is extremely challenging. Just think about looking through the window of your home and finding evidence for microbes in other houses on the street. That's extremely difficult. That's why it would cost more than $10 billion. Even then, the evidence will not be conclusive, finding the chemical fingerprints of microbes like oxygen, methane or water and so forth. But it could also be the result of geological activity, for example. But on the other hand, if you have a resident in any of the houses, then that resident might come to visit you, or you might find a tennis ball in your backyard, or you might see that the resident is constructing some project in their backyard that you can see from a distance. And my point is that even though residents might be less abundant, they might be much easier to detect, and therefore we should hedge our bets. And within the mainstream of astrobiology, we should put similar funds towards the search for microbes as we do towards the search for extraterrestrial intelligence.
I want to step back and talk about your recent article stating 3I Atlas could be made of antimatter. First of all, what is antimatter, and what makes you think that 3I Atlas could be made of it?
So antimatter is a type of particles that was realized when shortly after quantum mechanics was discovered about a century ago, that basically one of the solutions to the so-called Dirac equation of quantum mechanics is that you might find particles with the opposite properties. For example, the electron has a negative charge, electric charge, and there should be a particle with a positive charge. That was found actually around that after the prediction was made, and it's called a positron. And the protons have antiprotons that have the opposite charge, and so there are type of particles that are called the fermions. The electron is one of them, and they should have antiparticles. Now, in the Big Bang, early on, the temperatures were very high, so the abundance of particles and antiparticles was very similar, but there was a small surplus of particles over antiparticles. And because the density was so high shortly after the Big Bang, eventually, as the universe expanded and the matter cooled, eventually all the antiparticles annihilated with particles. So when a particle meets an antiparticle, they get destroyed, and you can end up with two photons, particles of light, out of that. So it's a mechanism for converting the mass of the particle and antiparticle to pure energy, just radiation. And in the early universe, that's exactly what happened. All the antiparticles, almost entirely, were destroyed by this process of annihilation as the universe expanded and cooled, and we were left with a little bit of the surplus of matter over antimatter. What created the surplus is still an unsolved problem in cosmology, but it's clear that we are made of matter, and not much antimatter survived after the Big Bang and the expansion of the universe. But you can make antimatter by energetic processes. For example, if you collide particles at high energies, and CERN has accelerators that make antimatter, like positrons and antiprotons. And just to give you a sense of how expensive it is, about 1% of a nanogram, so it's 10 to the power minus 11 of a gram of antimatter, it costs as much as a kilogram, 1,000 grams of gold. And if you wanted to make a gram of antimatter, it would cost about $5 quadrillion, more than the world's economy. And so it's extremely expensive, because otherwise you would say, oh, that's a perfect fuel, because you convert with 100% efficiency mass into energy, and there is nothing better than that. But unfortunately, this fuel is extremely expensive. Now, suppose aliens have access to some device that manufactures antimatter, and they made a spacecraft out of antimatter. I mean, that's a very remote possibility based on what we know on technology. But suppose they did that, would we be able to tell if 3I Atlas is made of antimatter? That's the question that I asked. And so the first thing I calculated was how much power will be generated by the fact that this object intercepts or scoops material from small dust particles in the solar system, the zodiacal dust that we know exists. And I found out, surprisingly, that it's actually the power that we see, that the luminosity that we see from the object. Of course, when things annihilate, they generate very, very energetic photons, particles of light. We don't see that. We see visible light. And so there could be a blanket that converts the very energetic photons to visible photons. But the best way to check it is by observing 3I Atlas with an X-ray telescope or a gamma ray telescope. And there are such telescopes in space. And as far as I know, at least the X-ray telescope, the Chandra X-ray Observatory, is planning to observe it. So that would be interesting as a curiosity, just to figure out that it's made of matter and not antimatter.
I want to shift gears and talk about the UAP issue. We have you on one end of the spectrum who is not afraid to speak up, who is not afraid to go against the stigma or whatever. And then you've got Neil deGrasse Tyson, who constantly seems to laugh off UFOs, UAP. Why do you think that there are so many scientists such as Neil deGrasse Tyson and others that laugh off or downplay, or in my opinion, what they do sort of continues the stigma, and they downplay the possibility that UAP exists and could represent some form of of non-human intelligence? What are your thoughts on that?
Well, first, I would like to explain that Neil deGrasse Tyson is a popularizer of science. He's not a practicing scientist. Over the past decade or two, he didn't write scientific papers. He wrote books that talk about, what other scientists discovered. It's very different, if you're a soccer player or a critic that sits in the audience and looks at what is happening on the field, And I published over the past month alone about 10 scientific papers. And I'm in the trenches doing science. So my point is that it's not so much about what he says versus what I say. It's about whether you are actually practicing the science or you're talking about it, because you're not in a position to protect science if you're not practicing it. Okay, and in fact, there are YouTubers and bloggers that criticize what I do. And how dare they? Let me ask it this way, because if they were to actually do the science, these are mainly dropouts from academia, people who didn't get an academic position, and somehow they have, you know, some number of likes on social media or some views on YouTube, but they don't have the credentials to represent science. They're not doing science. Okay, so you know, it's as if a movie critic would argue that a movie director should not be doing what they're doing. Like, who gave you that privilege? You don't know what it's like to actually make a movie, and in this case, to actually do the work of science, because you're not practicing it. You didn't get a position that allows you to practice it, and now from the sidelines, you are arguing that whoever has that privilege should not do what they are doing. Like, this sounds ridiculous to me. Now, the other reason it doesn't make a lot of sense is because the public cares a lot about this subject, and science is supported by the public. Okay, and so for scientists to stay in an ivory tower and argue, we know better. We don't listen to what the public really wants. We know that we want to figure out more details about microbes that might exist elsewhere. We will never look into the possibility of extraterrestrial intelligence just because we think the prospects of finding it are small. Now, once again, you know, if the mainstream was actually right in all of its assertions over the past few decades, I would say, okay, give them the benefit of the doubt. But when I look at my field, you know, when I started astrophysics, it was the folklore that the dark matter, you know, 85% of the matter in the universe, we don't know what it is. And it was popular to argue that these are the lightest supersymmetric particle. In other words, let's imagine a new symmetry of nature called supersymmetry. Everyone said it's natural, we should believe it. And then the Large Hadron Collider was funded at $10 billion to search for it and didn't find it in the natural range of parameters. So here's an example where the mainstream was, you know, not only quite confident that it exists, but, you know, people were giving awards to others for ideas related to supersymmetry. The dark matter was thought to be related to supersymmetry. We didn't find it. So the thing about it is science is a learning experience, and very often the mainstream takes the wrong path. But if you heard basically argue that nobody should deviate from that path, then everyone would go along this path and not find anything. And that happens again and again. And on the other hand, if you allowed diversity of ideas and then explore other paths on questions that matter to the public, I'm not saying things that are completely hypothetical. I mean, we exist. We know that we exist on a planet near the sun. There are billions of similar systems in the Milky Way galaxy. And why should it be considered highly speculative that something like us emerged even billions of years ago around other stars? That seems to me like common sense. And for that to be ridiculed, by people who do not practice science is completely inappropriate. And my point is, we should invest similar funds and effort in the research of trying to find evidence for intelligence. I know it for a fact that it would bring young kids to science, that it would bring funding from wealthy individuals. In fact, I was speaking just a few hours ago with them, and they were extremely excited. You know, all of my research over the past decade is funded by donors, not by federal funding agencies. And there is a huge amount of wealth that can be tapped for the benefit of science, which is not being tapped because the academic community is so hostile to what the public cares about. And so I would say what Neil deGrasse Tyson is doing is basically trying to be popular, okay? And in order to be popular within the scientific community or within the cohort of people that are in this echo chamber, he needs to repeat whatever is being said by others. And that is, that may give him more likes. But it's actually not the smart thing to do, because sometimes, especially when dealing with phase transformations, like a change in the paradigm. You have to get used to something completely new and imagine something like nobody expected quantum mechanics. I bet you that if Neil deGrasse Tyson existed a century ago and quantum mechanics, people were starting to discuss quantum mechanics, he would say, that's crazy. Like, how can reality behave in this way? What are you talking about? And if there was no research going in that direction, obviously it would be a self-fulfilling prophecy. Everyone would say classical physics is everything. Like Michelson, a very famous physicist, said, close to the end of the 19th century, said there is nothing else to discover. We will just figure out things to the 6th decimal point. That was his speech when a new laboratory at the University of Chicago was inaugurated. And how short-sighted that physicist was. And he was a practicing experimentalist. Because, just a decade later, special relativity was found. And 2 decades later, general relativity, a theory of gravity. And 3 decades later, quantum mechanics was discovered. So the guy thought that it's the end of physics and everything was. And so for Neil deGrasse Tyson to say, oh, this is ridiculous, that shows, a reluctance to learn something new. And, on a subject that the public is fascinated by. And the way I see it is simply as a missed opportunity for humanity if we will not invest significant funds in this frontier. And of course, in a decade, if funds are invested and we find something, everyone would say, including Neil deGrasse Tyson, of course, we all anticipated that. Check all these science fiction movies. I even said that it's quite likely that there might be life like us somewhere else. Like, they would completely change their because in order to be liked 10 years from now, it would appear that you need to advocate for it.
I'm just blown away by what you just said. Firstly, I had no idea. I figured Neil deGrasse Tyson would have published hundreds of scientific papers with as high in the media platform he is. But if you were to ask me how I would describe Dr. Avi Loeb, probably the 2 words that come to mind are humble and curious. If you were to ask me how to describe Neil deGrasse Tyson, I would say arrogant and closed-minded. And one of the things I absolutely love and why we support your work is this curiosity, this openness to being wrong, but saying, let's go look for the answers. Let's go find the data. And I think
that's the approach of a kid. I don't pretend to be the adult in the room. When Oumuamua did not show evidence for a cometary tail, I said the emperor has no clothes. And the adults in the room said, no, of course it has clothes, but they're invisible. They said they still insist, the comet experts still insist that Oumuamua is a dark comet where it has a cometary tail that is invisible. Can you believe that to be the mainstream view of comet experts? We don't see any evidence for cometary tail. They would say it's a dark comet. It's just like saying that an elephant is a zebra without stripes. No, it's a completely different animal. And by claiming that Oumuamua was a dark comet, you're basically suggesting that you know that it's a comet, and we just, didn't have the instruments to detect that cometary tail. But the point of the matter is we had a lot of instruments that could have detected evidence for cometary tail, and we didn't see any evidence for that. So why not admit it and say we don't know what it is?
And the thing, too, it's like we want more kids to become interested in science, and someone like yourself that has this almost childlike curiosity about the universe is far more inspirational to a young individual that is thinking about going into science versus a science sort of armchair quarterback that is saying, yeah, we already know what's going on. We understand the universe. There's nothing to see here.
There is something even more unusual about my history, and that is I served for 9 years as chair of the Harvard Astronomy Department, the longest serving chair. I chaired the board on physics and astronomy of the National Academies for 3 years. And I was a director of 2 centers. One is the founding director of the Black Hole Initiative at Harvard, and I'm still the director of the Institute for Theory and Computation. at Harvard, and I was a member of the President's Council on Science and Technology Policy at the White House. And so I served in many leadership positions of the establishment. And that did not deter me from my childhood curiosity. I see science not as a way to gain popularity or as a way to show off that I'm smarter than other people. That's not really, it's not about us. It's about us figuring nature. That is really the objective. So I think the priorities are miscalculated by people like Neil deGrasse Tyson, who wants to be liked. That's his main ambition. By my colleagues in academia, who want to be admired for being smart. And for that purpose, it doesn't really matter whether you describe reality or not. You will try to avoid any mistake by not taking risks. And you can spend decades in intellectual gymnastics on things that the public doesn't really care about. You can imagine extra dimensions in the context of string theory. That's the mainstream of particle physics. For 40 years, did not produce a testable prediction. And moreover, there is no clear evidence that this might be the actual description of reality. And so people can get entrenched in these echo chambers where they basically have no oversight. They keep feeding themselves with ideas that may have nothing to do with nature, and they don't care about what the public would like to know, because their goal is to impress their peers. It's a system that does not have any oversight. And my point is, by interacting with the public, we can keep it alive and honest. And, if I make a mistake, that, it's part of the learning process. That's the way we learn. So why herding everyone to not deviate from the beaten path? I get a lot of aggressive comments from some of my colleagues, and I simply ignore it, because that's not, my motivation is not to be liked by them.
I love that. And I think all of those individuals, those so-called scientists and some scientists, I think they're really doing a disservice to humanity. And wow, it just is so short-sighted. Now, Dr. Loeb, as you know, Senators Chuck Schumer, Mike Rounds, and Kirsten Gillibrand have submitted the UAP Disclosure Act for inclusion in the 2026 National Defense Authorization Act, otherwise known as NDAA. We know the government loves their acronyms. Now, it was also recently co-sponsored by Senator Todd Young. Now, the legislation uses the phrase non-human intelligence over 20 times, deals with crashed UFOs and bodies in possession of defense contractors, and it creates a White House advisory board, which I would love to see you on personally, to deal with the UFO issue. Now, Senator Mike Rounds has publicly stated that this will likely pass in the Senate, but will face hurdles in the House. This is actually the third time they're trying to get this over the finish line. Dr. Loeb, what is your message to lawmakers on why they should support and approve the UAP Disclosure Act?
Well, I think if there are things that are not fully understood within government, which it sounds like there are, because we received 3 reports from the Director of National Intelligence. Most recently, Tulsi Gabbard hinted that she knows about things that are not fully understood. These could be a matter of national security threat to the US if they are produced by adversarial nations. But if they are kept under wraps, and you don't include the most brilliant minds to analyze them and help government figure them out. You can sign academics on NDAs, that's not an issue, but you want to employ scientists, not bureaucrats, to figure out what these things are. And I think we should get to the bottom of it. So even if these are, perhaps human-made, I think the Department of Defense will benefit from a collection of individuals that look into the evidence and advise them about what needs to be done to figure it out. And as of now, we just have the All-Domain Anomaly Resolution Office in the Pentagon. I visited them just before my briefing in Congress at the end of April, and I asked them, what do you make of all the reports that were filed in the past? And they said that they haven't found any clear evidence for something beyond this earth. But in many cases, they can't really figure it out because they have limited data. Now, they don't employ the best quality scientists. And I don't know if what they're telling me is the full picture. And I don't know if they have access to all the evidence that government has at its possession. And so my point to Congress is, let's get to the bottom of it, because it could be a matter of national security, and we cannot trust people who are not qualified to give us the best advice on scientific matters. These are not scientists that are looking at the data if they do it at Aero. And I would much rather have a committee that is appointed by the President of the United States and advises the President as to whether there is something there that we should look into more closely. And of course, if it represents technologies beyond Earth, that would have huge implications for humanity at large. It would potentially have implications for technologies we don't possess. We should just get to the bottom of it rather than talk around it. And it shouldn't be too complicated, in terms of how much funding needs to be allocated and how much effort needs to. I mean, this is more important than looking back at the JFK assassination, because it's not a political matter. It's either a national security matter or a scientific matter.
I couldn't agree more. And folks, I encourage everybody watching this show to reach out to their lawmakers and call them, email them, and demand the approval of the UAP Disclosure Act for the 2026 NDAA. Well, Dr. Loeb, thank you so much for your time. I don't have kids, but I have to say, if I had kids, I would certainly want them to grow up and follow in your footsteps. I think what you do for science, your curiosity, your openness, your willingness to be wrong, that's inspirational. And I certainly hope if there are any young individuals that are watching this, you'll see what Dr. Loeb is doing with his scientific career, because I just think it's fantastic.
I just wanted to make one clarification that, I was asked, what do I want to be remembered by? And I said, my future work, because the best is yet to come. So stay tuned. What I did so far is just the beginning.
I absolutely love that. Dr. Loeb, thank you for joining us, and hope to see you back soon.
Same here. Thank you.
Folks, if you enjoyed this interview with Dr. Avi Loeb, you will love this next episode. Thank you for tuning in, and if you love our channel, please hit that subscribe button and tell your friends about our show. See you next time.